Let me give you another example of calculating the price elasticity demand. In this example right here, we had a simple linear demand curve. Along a linear demand curve, the price elasticity is going to be different at every point. Suppose we had a demand curve that looked like this. Q equals 100 times P to the minus 1 power. And I ask you, for this demand function, calculate the price elasticity demand. How would you proceed? For this demand function, calculate the price elasticity demand. Well, what would be a good way to start when I ask you to calculate the price elasticity demand? What would be a good way to begin? Yeah, just use the definition of what the elasticity is. And the most convenient definition would be this. The elasticity of Q with respect to P is dQ dP times P over Q. This would be more convenient than the 1 dQ over Q over dP over P. What is dQ dP in this case? Exactly. It's negative 100 times P to the minus 2. Or it's, as you said, Jay, negative 100 divided by P squared. Okay. That's dQ dP. So then what do we have to do with that dQ dP? Exactly. Multiply it by P over Q, and then we'll have the elasticity. Multiply it by P over Q. Now, when we multiply it by P over Q, let's substitute in what Q is. Q in terms of P is just 100 times P to the minus 1. So we are multiplying this. Minus 100 times P to the minus 2 power times P, and then substitute in for Q, 100 P to the minus 1. Now we got it all in terms of P. And notice what happens when we multiply minus 100 times P to the minus 2 times P to the 1, what do you get? When you multiply this times this, you get minus 100 P to what power? When you multiply this times that, what do you get? P to the negative 1 power. You just add the exponents. But then you're dividing by 100 P to the minus 1. So when you divide these two things, what do you get? Negative 1. Now, in this case, what's interesting is the price elasticity demand is always minus 1. It turns out that the price elasticity demand doesn't depend on the value of P in this particular case. This exponent up here on price, when you have a multiplicative form like this, the exponent on price is just the price elasticity demand. So for this particular demand curve, the price elasticity demand is always minus 1. And if you graph this demand curve, what does it look like? It looks like this. It's a rectangular hyperbola. It asymptotically approaches the horizontal axis but never quite reaches it. It asymptotically approaches the vertical axis as P approaches 0. So the demand curve looks like this. And for this particular demand curve, the price elasticity demand is always minus 1. Okay. Now, I could generalize this formula a little bit to say Q equals alpha times P to the minus n power, where n is a positive number. And if you mathematically work out this case, the price elasticity demand is always minus n, whatever that exponent is. This would be an example of a constant price elasticity demand curve. it would have a constant price elasticity of demand that's always minus n. I'll let you work that out mathematically.